transforming, which means moving, transforming exponential functions. So today we're working on how those exponential graphs move left, right, they squish or they pull away from the x-axis. So the original equation is always y equals a times b to the x power. Okay, so some vocabulary we're going to be talking about. First, a vertical stretch. This is when the graph pulls away from the x-axis. Pulls away from the x-axis is when the absolute value of the a, so whatever a is, if the absolute value of it is greater than 1. So this is when the absolute value of, oops, I wrote x. Absolute value of a, not x. The absolute value of a is greater than the number 1. It pulls away from the x-axis when the absolute value is greater than 1. So what this would look like is if I had a graph, and let's say my original graph was like this. If something is pulling away, if that a value, the absolute value of the a, is bigger than 1, it's going to pull away faster. So it might just go up faster. Then we have a vertical compression. This pushes the graph towards the x-axis. Pushes the graph towards the x-axis. And this is when when the absolute value of a is less than 1. A vertical compression happens when the absolute value of a is less than 1, and it looks like it pushes the graph towards the x-axis. So if I have a graph, it looks like that. If something gets pushed closer to the x-axis, it's going to be a little bit closer. It's just not going to rise as much. So when that a value, when the absolute value of a is bigger than 1, it pulls farther away from x. When it's less than 1, it gets closer to the x-axis. If a is less than 0, so if a is negative, the graph will reflect over the x-axis. So if that a value, the first number there, if it's a negative, it's going to reflect over the x-axis. So if I have a graph that's going up like this, it's instead going to go down like that. And then last, adding a constant. We'll move the graph up or down. Adding a constant will move the graph up or down. So for instance, if I have y equals 3 times 2 to the x power, if I change it to 3 times 2 to the x power, and then I put a plus 5 at the end. So this would be my constant. That means wherever this graph, the original graph is, the second graph is now going to be up 5 units. If it's a positive, it's a plus sign. It's going to be up that many units. If it's a subtraction sign or a negative sign, it'll be down. So this symbol will say if it's moving up or down. Plus moves up, minus sign means you move down. Okay, let's start with example 1 then. Sure, everyone has that? Okay, for example 1, for the first few examples, or the first few ones we do with example 1, the original equation we're going to keep using is y equals 1.5 to the x power. And then I'm going to keep giving you new equations, and I want to see how they moved from this original equation to this new equation. You're going to make a table. The directions say make a table, graph, describe end behavior, and find the y-intercept. So the directions want us to do all of these things. So we're going to have to create a table of values, we're going to graph, we're going to describe the end behavior, and we have to say what the y-intercept is. Okay, for letter A, example 1A, the equation we're using is f of x equals 0.3 times 1.5 to the x power. So if I started at 1.5 to the x power and then I moved to 0.3 times 1.5 to the x power, that a value is less than 1, so it means the graph is going to be more squished. It's going to be closer to the x-axis. The first thing we're going to do is make a table of values. The x's that I would like you to use are from -2 up until the number 5. From -2 to +5. I want you to tell me what the y values are for the equation and what are the y values from the original 1.5 to the x power. If you're using Desmos, let me double check that you know how to change the x's if they don't give you all the x's. So if I'm putting in 0.3, if I go to Desmos, type in the 0.3 parenthesis 1.5 to the x power. Okay, if you're on Desmos, if you hit the gear shift to give you the table, hit the table there. So it only gave me -2 to +2, and I still need to get 3, 4, 5. You can either just change -2, or you could just type in a 3 down there, or you could just go down to the empty spot on the bottom and type in a 3 there, a 4 there, and a 5 there. You can just add them on the bottom if you want, or you can just add them anywhere. If you're using the graphing calculator, you can do both of them at the same time. So if you go into your y equals 1, make that the 0.3, parentheses 1.5 to the x power. Second graph is the 1.5 to the x power. Okay, go into second and graph to get your table. Okay, write all those down. So from -2 to +5. And we are going to graph these both on the same exact graph. So grab your graph paper. Look at your x's and your y's on how big you need to make your graph. Looks like from my x's, I need to make sure I hit at least +5. My y's, I need to make sure I hit about 8. So on your y-axis, give yourself enough space to go 8 up. If you want to do them in 2 different colors, sometimes it helps if you graph them with 2 different colors since you're graphing them on the same graph. Make sure your y-axis, you have enough space to hit +8. When you're graphing, I noticed when you guys did your worksheet last week, when you had to graph, some of your graphs are awful. They look like an earthquake happened. You're not drawing in straight lines from dot to dot. It should be a nice smooth curve. So please, make sure you guys are all doing this graph right now. But it should be connecting with a nice smooth curve. And the graph goes on forever. It doesn't stop at that last dot that you drew. I have a lot of you guys that stop your graphs. These graphs go on forever. They're continuous. Okay, so that graph I just did, that is for the one that has the 0.3 on it. And then on the same graph what our original 1.5 graph will look like. And that's the graph for y equals 1.5 to the x. So as you're graphing, look at your graph. Is it nice and pretty? Or is it a complete mess? Make it a nice smooth curve. me, that's my original graph. I wanted to know how it moved to get to the 0.3. So 0.3 is less than 1. So that's when I wrote in my notes, if the absolute value is less than 1, it's going to be a compression. It gets closer to the x-axis. So that's why the second graph, or the green graph, is closer to the x-axis, is because of that 0.3. Okay, then it asks the directions, say we're going to make the table, we're going to graph. Now we have to do the end behavior. We're just doing the end behavior to the 0.3 graph. So remember from last week, end behavior as x approaches infinity, y approaches something, and then as x approaches negative infinity, y approaches something. So as the x is getting bigger, figure out what's going on with those y values. Either look at the graph or look at your table. As x is approaching infinity, so as the x's are getting bigger. So if I go to my table, I'm looking at my blue numbers here. As my numbers are getting bigger, think about what's going on with those blue values. Or go to your graph, or looking at this graph. As the numbers are getting bigger, my graph, the y values, will keep going up forever. So they're going to approach infinity because they're getting bigger forever. Okay, as the x's are getting smaller, as they're getting closer to negative infinity, what's happening to those y values? So as my x's are going smaller, so as I'm going up for my smaller numbers, what's going on with those blue digits? They're getting smaller, smaller, smaller. They're getting really, really close to the number 0. So y is approaching 0. Or if you look at the graph, as you get smaller, the graph is getting closer to the 0. And then the last thing it asks is the Y-intercept. It's always 0, something. You can either look at your table of values, it's at 0, 0.3, or on the equation, it's your A value. It's right, it's the first number listed. That's your Y-intercept. Okay, if you want to cut those out and glue the graph into your notes, and then we're going to do this again. Make sure your notes are nice and neat and easy for you to read them. Okay, we're going to do the same thing. Our original equation will still be the 1.5x, or to the x power. Okay, this is 1b. Now I'm using f of x equals negative 2 times 1.5 to the x power. Remember, the original one is the 1.5 to the x. So I want to know how it changed from the original equation to this new one. Oh. Did it call 911? You can't hang up on 911. Take your phone out. They're going to call you back. Take your phone out. If they call you back, you have to answer it. Tell them it was an accident. Yeah, you can't ever just like ignore 911. I know, but that's why you can't just ignore them, because then they're going to think something actually happened, and yeah. We have to make the table, graph it, end behavior, and what's the y-intercept. So for this one, for the x values, we're going to use -4 up until +2. -4 to +2. That row or that column with the 1.5 to the x, you really don't need to put it since we already used it from the last equation. You can just copy that down if you want to. Okay, go ahead and put both of those into your graphing calculators and write down the y values. Okay. When you look at your x's and y's, figure out how big you need to make your graph. So look at what's the smallest x's, what's the biggest x's, smallest y, biggest y. Figure out how big you need to make your your whole graph. So it looks like it doesn't need to be too big. I would say probably 5 in both directions. Okay, everyone's doing this on graph paper. When I walk around, I should see your graphs, not Desmos. Do not show me Desmos and tell me that's your graph, because some of you still don't know how to graph by hand. If you want to use 2 different colors, sometimes that helps. Oops. So when you look at your 2 graphs, your original graph is up here in quadrant 1 and 2. The graph with the -2 is down in quadrant 3 and 4 because of that negative on the A. So the negative reflects it over the x-axis. Look at your graph, make sure it has a nice smooth curve to it. Look at your graphs, are they nice and pretty? Okay, now do end behavior. Just for the -2 equation. You don't need to do it for the original. End behavior. As x approaches infinity, y approaches something. As x approaches -infinity, y approaches something. Okay, see if you can finish the end behavior by yourself. X's get bigger. So as I'm going from left to right, my green graph, as I go left to right, the green graph is going down. It has an arrow on it, so it's going to go down forever. So it's going to keep getting smaller and smaller and smaller. So it's going to approach negative infinity. As the x's are getting smaller, so as I'm going backwards, the y values are getting closer and closer to 0. And then the last thing we need is the y-intercept. That's always 0, comma. You can either get it from the table or it's just your a value in the equation. So 0, comma, negative 2. Okay, now this one you're going to do on your own, or you can work on it with the people sitting around you. For these, the directions say to graph, find the end behavior, and the y-intercept. Okay, go ahead and do f of x equals negative 0.5 times 1.5 to the x power. Done with that one, check your answers, especially the end behavior, with your groups. And then I'll have another one for you to do up here. Okay, for question 1, your graph should look something like this. And then the end behavior is as x approaches infinity, y approaches negative infinity. Then as x approaches negative infinity, y approaches 0. And the y-intercept was at 0, negative 0.5. Questions on number 1? Okay, check number 2 then. Your graph should look like this. And the end behavior is as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches 0. And the y-intercept was 0, 4. Questions on any of those? Okay, we're going to continue doing more like this, except we're not going to use 1.5. So for all of these, we kept using 1.5 as the original equation. So now we're going to change it. For example 2, we're going to use y equals 0.6 to the x power. Again, we're still going to make a table, graph, end behavior, y-intercept. So 2a is going to be f of x equals negative 3 times 0.6 to the x power. So I know that the a value is negative, so I know it's going to be reflected over the x-axis. The a value is 3, so it's going to pull away from the x-axis as well. First, we're going to make a table of values. The x's I would like you to use are negative 1, 0, 1, 2, 3. So from negative 1 to positive 3. We're going to find the y values for negative 3 times 0.6 to the x power, and then the original equation of 0.6 to the x power. Okay, either use Desmos or your graphing calculator and fill out your table of values. Just use x's from negative 1 to positive 3. Okay, looking at your x's and your y's, determine how big do you need to make your graph. So it looks like all the numbers are pretty small. They fall between 0 and 5. Or I guess 5 in all directions. Okay, graph both equations on the same graph. Everyone should be graphing. I should see everybody graphing this on graph paper, not just showing me your Desmos. So you can do it on your iPad. If you pulled up the notes on Canvas, you can do this on your iPad. When you're done, look at your graphs. They should be nice and smooth curves. They should have arrows on both sides. The graph does not just end at whatever the last dot was. It does go on forever. So make sure there's arrows on there, because if not, you're going to get that marked wrong on a test. So the graph that had the -3, you'll notice it was reflected. It's down in quadrant 3 and 4. It also had a 3, so it's pulled away farther from the x-axis. Okay, if you want to cut that out and glue that into your notes, then we need to do end behavior and the y-intercept. So just for that -3 graph, go ahead and figure out what's the end behavior. And then what's the y-intercept? So as the x's are getting bigger, what happens? As the y's are, or as the x's are getting smaller, what happens? Bigger to the right, the graph is getting closer and closer to 0. As the x's are getting smaller, so as I'm going to the left, the graph is going down forever, so it's going to -infinity. Okay, last thing, what's the y-intercept? Zero comma, whatever the a value is, -3. So 0 comma -3. Okay, we're going to stop there today. We will finish these notes tomorrow. You do not have homework except for those of you that never finished that worksheet that was due today.